Hi students, today our topic is meter bridge. Okay, now here meter bridge is the practical application of Wheatstone bridge. Okay, now is the practical application of Wheatstone bridge. Okay, first of all, construction. Consider 1 meter wire. Okay, uniformly cross-sectional area. Okay, first of all, consider 1 meter wire. It having uniformly cross-sectional area, stretched, taut. Okay, clamped between two copper strips. Okay, clamped between two copper strips. It is a meter wire. 1 meter wire. First of all, consider 1 meter, that means 100 centimeter, uniformly cross sectional area. Consider 1 meter wire. Okay, consider 1 meter wire, uniformly cross sectional area. Okay, fixed in between two copper strips. It is stretched. Okay, fixed in between two copper strips. These two copper strips shape is L shape. Okay, these two copper strip shape is L. Understood? In between another copper strip. In between another copper strips. Understood? Okay. Now, here this is the meter scale. This one is meter scale. Okay. This is wire, 1 meter wire. Now, this one is meter scale. Okay. This one is meter scale. Now, here wire, which type of wire is taken here? Li. Okay, here taken wire is Li. Li in the sense manganese or constant, like the type of wires. Why we consider Li? So this type of materials are independent on resistance, is independent on temperature. Okay, almost on independent on temperature because of resistance is independent on temperature. Okay, that's why we consider here this type of wires. Here considerable wire is Li. Li in the sense manganese constants, like the type of wires. Why we consider that type of wires means, so that type of wires almost all resistance is almost all independent on temperature. If temperature is increased, its resistance, okay, does not change. If in case it change, that is negligible. That is negligible. Okay, that's why we consider wire is Li. Okay, here two gaps. In between two gaps placed. In left gap, unknown resistance. Okay, in right gap, standard known resistance. RB in the sense resistance box. Okay, now here this one is unknown resistance. This one is noun standard resistance. Okay, in left gap, unknown resistance, in right gap. Okay, noun standard resistance. Okay, now here battery is connected. Battery is connected with these two terminals. It is a key. Battery is connected here. Okay, battery is connected. Give the names. A. This is B. This is C. Okay. Now battery is connected in between the points of A and C. In between the points of A and C. Next, from here at B, connected one galvanometer with the help of high resistance box. With the help of high resistance box. This is the galvanometer. Okay. Here this high resistance box helps to the galvanometer from high currents. Okay. Here high resistance box protect the galvanometer from high currents. Understood? What is the use of high resistor here? High resistor main purpose is to protect the galvanometer from high currents. Okay. Next, galvanometer connected to the one jockey. Jockey in the sense here. Jockey, it is a metal rod. Metal rod with a sharp knife edge. Okay, with a sharp knife edge. That means here, like this one. Okay, with a sharp knife edge. Okay, so that is jockey. Jockey is a metal rod with a sharp knife edge. Okay, so one end connected with the high resistance box and it is connected to the point B. Another end connected with the jockey. Connected with the jockey. Now this jockey placed on the wire. Here galvanometer shows the deflections. Galvanometer shows the deflections. Okay, galvanometer shows the deflections. If this jockey is placed on here, it shows deflection. Okay, placed here, it shows deflection. At certain point, it shows the zero deflection. Okay, zero deflection in the sense there is no deflection in that galvanometer. Okay, exactly needle lies at zero. Exactly needle lies at zero. That is balancing condition. That is balancing condition. Once again, for example, it is a jockey. You are placed on the wire. Here galvanometer shows the deflection. Okay, if in case you are placed here, it shows. If in case you are placed here, it shows zero deflection. Zero deflection means total bridge is balanced. Okay, total bridge is balanced. Understood? For example, it shows the zero deflection at certain point. That point is D. That point is D. Okay. Now, in this length, here balancing length is L. In this length also, resistance is there. For example, lambda is the resistance per centimeter. Understood? Here lambda is the resistance per centimeter. Now here balancing length is L. That means resistance in AD. Resistance in AD is equal to lambda into L. Resistance in AD is equal to lambda into L. Okay. What about remaining length? Remaining length total 100 centimeters. Okay. Up to here L. Remaining length is 100 minus L. In this DC, resistance is resistance in DC is equal to what at one 100 minus L into lambda. Okay, here what is lambda? Resistance per centimeter. Understood? Okay. Once again, first of all, wire. Okay, uniformly cross-sectional area. It is clamped in between two copper strips. Another copper strip is this one. Here two gaps are there. In left gap, unknown resistance. In right gap, now standard resistance. Simply resistance box. Here, AC arm connected with battery with the help of key. Okay. Next, BD. BD arm connected the galvanometer with the help of high resistance box. High resistance box main purpose is to protect the galvanometer from high currents. Okay. And galvanometer another end is connected with jockey. Jockey in the sense metal rod with sharp knife edge. Okay. Now this jockey is placed on this wire. So it shows the deflections at certain point. It shows the zero deflection. That means bridge is balanced. Bridge is balanced. Understood? Okay. So for our convenient, I draw here Wheatstone bridge. See, A to B. Okay, it is unknown resistance. B, C, it is standard resistance. Now, this point is D. D means resistance of AD. Okay, resistance of AD. Now, this one, resistance of DC. Now, it is the galvanometer. This one is galvanometer. See, in between B and D. Okay, now here, internals, battery is connected. Battery is connected with the help of key. Okay, battery MF is E. So, this is the Wheatstone bridge. Wheatstone bridge. Here, galvanometer shows that zero deflection means current passing through the galvanometer is what at one? Zero. That means point B, point D are having same potential. V suffix B is equal to V suffix D. Both are having same potential. Current I. Here, current is, this one is I1, I2, I3. This one is I4. Okay, you know already Wheatstone bridge concept. In balancing condition, balancing condition means current passing through the galvanometer is zero. On that case, R by S is equal to resistance of AD by resistance of DC. Resistance of AD by resistance of DC. R by S is equal to resistance of AD means lambda into L. Okay. 100 minus L into lambda. Lambda cancel. Lambda cancel. Understood? See, R by S is equal to resistance of AD by resistance of DC because in balancing condition. Okay. So, R by S is equal to L by 100 minus L. Lambda cancel. R by S is equal to L by 100 minus L. Here unknown resistance is R. Unknown resistance is R. Unknown resistance is R. So simply you write as R is equal to S into L by 100 minus L. Okay, 100 minus L. Are understood? Listen, if in case a standard resistance is changes. Okay, S change. S change means at the same time balancing length is also changed. Okay, this experiment is repeated number of times to eliminate the error. To eliminate the error, finally you consider average value. Okay, finally you consider average value. Okay, so to remove the error, okay, or to decreasing the error, okay, balancing point adjusted middle of the wire. Okay, if in case you are adjusted, okay, balancing point at nearer to the midpoint of the wire, okay, at nearer to the midpoint of the wire, on that case error is eliminated. Understood? To eliminate the error, okay, balancing point adjusted nearer to the midpoint. Understood? Okay, so here R is unknown resistance. Yes, L by 100 minus L. It is a formation. Now, some important points. See, in left gap, okay, in left gap, resistance is increased. Or in right gap, resistance is decreases. Okay, in left gap, resistance is increased. Or resistance in right gap is decreases. Okay, in this case, this balancing length shift so towards the right. Okay, if R increases means L is also increase. Okay, now balancing point shift towards the right. Okay, balancing point shift towards the right. Okay, shift towards the right. If resistance in left gap increase or resistance in right gap is decrease, reverse order. If resistance in left gap decrease or resistance in right gap is increase, that means balancing point shift towards left. Okay, shift towards left. Understood? Okay, next, these 2 points are important. Next point, if one metallic wire is placed in left gap, okay, in left gap, which one is placed? Metallic wire. Okay, metallic wire is placed and it is heated. That wire is heated. Heated in the sense temperature is increased. Okay, temperature increase means in metallic wire resistance is also increase. So balancing point shift towards the right. Balancing point shift towards the right. Okay, shift towards the right. Understood? Once again, left gap. In left gap, place the metallic wire. It is heated in the sense temperature is increased. If temperature increase, what about resistance? Increase. Balancing point shift towards the right. For example, in left gap, in this left gap, placed the semiconductor wire. And it is heated. Heated in the sense temperature is increased. Temperature is increased means what about its resistance? Decrease. In semiconductor wires, if the temperature is increased, resistance is decreased. If the resistance is decreased in the sense balancing point shifting towards the left. Okay, So towards the left. Okay, balancing point. Balancing point shift towards the left. Okay, next drawbacks in this meter bridge. Drawbacks: it is not useful to find out very low resistances and very high resistances. Because of to find out the very low resistances, see here some bolts are there. Okay, some bolts are there. These are also having some resistance. That means it not gives the correct value for low resistances. Okay, and also here meter wire, 1 meter wire, some of the wire is locked in strips. Some of the wire is locked in strips. That means this wire may be not exactly 100 centimeters, not exactly 100 centimeters, 100 centimeters in the sense 1 meter. Okay, next what are the uses of meter bridge? What are the uses of meter bridge? Main purpose is to find out the unknown resistance. Okay, to find out the unknown resistance. Its main purpose is to find out the unknown resistance. Next, to comparison the resistances of two wires. Okay, to comparison the resistance of two wires. Okay, next to find out the specific resistance of the wire. To find out the specific resistance of the wire. Okay, next to verify the series and parallel combinations. Understood? Well, here uses, main uses is to find out the unknown resistances, to comparison the resistance of the two wires, to find out the specific resistance of the wires, and to verify the series and parallel combinations of the wires. Understood? Okay, so these are the uses. It is not useful to find out high resistances and low resistances. Okay, cause I am also explained some bolts are there. These bolts are also having some resistance, and this wire not exactly, okay, maybe not exactly 100 centimeters, because of it is locked. Okay, it is locked. That's why it's not, maybe it's not useful. Understood? Okay, this is the meter bridge.